Okay, this is the answers for Weka week 9. So it says at minute 250 in the video, you can see 10 different accuracies. This is not because they use tenfold cross-validation. Why are there 10 different accuracy figures? So that's about here. So he's working with this data. He's doing a J48 tree. Set the percentage split to 90%, so he's not even using cross-validation, but this wouldn't matter actually. And he did it, and he got 90 this accuracy here, but then he repeats it with a different seed each time. So why does he do that, and what's going on here? Well, because when we use a different seed, we're choosing a different sample on which to do this splitting. So he's splitting at 90% and 10%. So, but he's choosing, when you use a different seed, you choose a different sample for the 90% and also for the 10%. So of course, each time you choose a different sample, you're probably going to get different accuracy. So he's gets different accuracies 10 different times. And so to get kind of a better representation of the true accuracy of the algorithm, we might want to take the mean of these and say that that's the true accuracy. Okay, and then there's another concept, and that is the concept of the standard deviation, which is measures like how much variation there is in these numbers. Like, are they all really close to that mean that we just mentioned, or are they far away? Like maybe the mean was 80, and we're getting numbers like 79, which is very close to 80, and 81, which is very close to 80. But you might also be getting, instead of that, you might be getting, the mean might still be 80, but you might be getting numbers like 60 and 100. 60 and 100. Those are much further away. So that would mean that would be a different situation. So in the first situation, we would say the standard deviation is small. That means the variation from the mean is small. Whereas in the second scenario, when we're getting 60 and 100, then we'd say the standard deviation is larger. The variation is larger. So we'd like to know whether the variation is large or small. If it's small, that's better. That means we're not getting a lot of bouncing around from that mean. So that's probably better. It means we're sort of more confident in that number. So that's the answer to number 1. After opening up the experimenter, what is the first button you click to begin? So that's here, and you click New. Unless you've already have an experiment and you've saved it, then you can use this button to open it. What would you say is the value of repeating the experiment 10 times as opposed to once? Well, we just talked about that here. You get kind of a better measure of the accuracy. Once he goes to the Analyze panel, what is the first button he has to click there? So I guess that means when you go here, so I can't do it because I didn't run it yet, but you would click, I think Perform Test is the first button you have to, well, you would set these, and then you would perform the test, and you get the answer. Okay, so you can, after you've run the experiment, you can save the result to a CSV file, as he did, using percentage split, as he did. And what is the small, so when you do that, you'll see the true positive rate there, and you can determine which is the smallest true positive rate. And also, what's another name for the true positive rate? So we can look this up, and the true positive rate is also called the sensitivity. Okay, so you can load many So once you click New, now you can add in many different data sets, and hopefully you're going to add in many variations of the same data set when you're doing the experiment. And then you can add in many different algorithms as well. So we could do 0R, and we could add in J48, and so on. And then you can, let's see if what do we actually have to do here? So you'd click on Run. Now, sometimes you'll get errors, and it's usually hard to figure out which data set or which algorithm caused the error. There might be some way of figuring it out, but anyway, it's sort of hard to figure it out if you get an error. So you sort of have to go back and delete stuff and see if you don't get an error. Okay, now to test this, you click Experiment. Sorry, I guess that's what you have to do first. And then you can decide what you want to see here. So if you want to see percentage correct, set it at that. And you can select other options. Like we said, the output format, you could choose, I think, CSV. Is this where you set it to CSV? I forget, maybe. And let's do that. And let's perform the test. So you get to see, you don't see the results here, do we? So I guess we have to set that at maybe this. Try it again. Yeah, now we can see it. So when we do that, we get this kind of result. And the V here means that the tree did significantly better, statistically better. I think that you set the significance at 0.5, and then it does statistically better based on this significance level than this was. And this one also is statistically better than this one, which is expected, right? This is J48 tree versus the 0R. If there was an asterisk there, it would mean it was statistically worse. So here, what does a star next to an output mean? We just said that. And it's a result in comparison to this score. Okay, number 9 is explain how we add a dataset to the knowledge flow interface. He adds the iris dataset. On my version of Weka, the process is slightly different than in his video. So let's take a look at that. So we get this, and we want to go to data sources. So sources means where you're going to read the data from. Sinks means if you want to save the result or save a file later on. Okay, but source, so if we want to load an ARF, what you do is you click on here, and then you click on here. And then I think you right-click and you do configure. And then you find the file. You can load the iris. Okay, and that's how you load a file. Now, if you want to see what are the templates, you can go here, and you can get a whole template. Let's try that. So you get this. So you start out with the ARF, class assigner, class validation, folder maker, choose the algorithm, classifier performance evaluator, model performance, text viewer. Let's try to load something in here. Let's load the iris. Okay, and then maybe we can run it. And then maybe we can show the chart. And so we've seen this kind of chart before. So I guess the answer to the next question is that we need the model performance chart. Right. This one shows you that. No, sorry. So if you want to show the results of that, you can see it here. Okay, so this question was, how can we see a graph like that? And we can see that you need this model performance chart. Is that right? I guess so. There's some pre-made templates. Give the name of one of them, so we just saw the templates. Open up the Java documentation. So you go to where Java is stored. Look up here. And you go to the docs. And I think it's here, index.html. Yeah. So this is the documentation. So this is what's called the Java documentation, because Weka is written in the programming language Java. The entire program is written in Java, including the interfaces that we use, like the Explorer, and all of these are all written in Java. That's why they're so ugly. No, maybe you can make good programs, make nice looking programs in Java as well. But anyway, they're all written in Java. And so this is the when you write a program in Java, you can make it automatically produce this kind of documentation. So that's what this has done, what they've done here. So we have the documentation. So it says here, open up the Java documentation. It shows the documents for J48. Find the documentation for random forest and take a screenshot of it. Let's see if we can find that. So I think you can search through here, classifiers, trees probably. You probably find it in here. So there's a J48 here, but you can also find it probably in random forest. Random forest. So here it is. So it's hard for us to read all of this because we don't know Java, but some of it we can understand because we can look at some of the options and recognize them. Anyway, that's how you would do it. Now, we could go to here and we might find random forest that way as well. It's the same documentation, just a different way to get to it. Okay, I think here the first line he types into the CLI gives him an error, and I think that's because he forgot to type Java at the beginning. Okay, actually no, he did type in Java, but he still got basically an error response. And I guess that's because he didn't put in the extra, they're called extra flags, like we need a C, I think, and an M in there to get it to work properly. So here, if you copy this directly into you have to write Java at the beginning, then Weka classifiers.trees.j48, and then you put this in, and now it should work. You would need Java at the beginning. And the Java has to be, I think it has to be small letters. And he does say something about you need to have the full path to the data set. So you need to write something like this. And I guess the T here is for the data set. So you might do the minus T, these are called the flags, the minus C, the minus F. I'm sorry, they're called the switches, or maybe they're called flags. Minus C, minus M, minus T. And the T must be for the database. And you have to put the data set, and you have to put the full path name to the data set. You can't just write iris. Also, you can't use these kinds of curly quotation marks here. You have to use just straight ones, so you can't copy and paste from Microsoft.